Hi, I'm Tanisha and you're watching this video with justtutors.com. Today we are going to learn about trigonometry. In this video, we'll first learn about some trigonometric identities and then we'll try some sample problems on it. So before we move on to the topic, let us try some warm-up question first. If you want to try the questions by yourself, you can pause the video and match your answers later. So we'll start with the first question that says to evaluate sine 39 degrees minus cos 51 degrees. The answer for this is gonna be 0 because we just need to change sine 39 degrees into sine 90 degrees minus theta. That can be written as sine 90 degrees minus 51 degrees, which in turn would change into cos 51 degrees. Hence would give us a 0. We'll start with the part 2. The answer for this will gonna be 0 again because we need to change cot 34 degrees and we can change it like cot 90 degrees, take away 56 degrees, and which will change into tan 56 degrees, and hence the answer would be 0. Let's try question number 2 that says solve sec 50 degrees times sine 40 degrees add cos 40 degrees times cosec 50 degrees. So we just need to change these two ratios here. So sec theta can be written as sec 90 degrees minus 40 degrees and cosec can be written as cosec 90 degrees minus 40 degrees. So sec will change into cosec 40 degrees and cosec will change into sec 40 degrees, and we can find out that the answer for this question is 2. Pat your back if you've got the answer absolutely correct. Congratulations. Now let's move on to the topic for today, which is learning about the trigonometric identities. So let us say that we have a right angle triangle ABC, which is right angled at C, and we know that AC is equal to A, AB is equal to C, and BC is equal to B. Now we need to apply the Pythagoras theorem here, which says that the square of the side that is opposite to the right angle is equal to the sum of the squares of the other two sides. That means BA square is equal to AC square plus BC square. So we've written that here already. Now we need to divide the whole equation by AB whole square. So I think that's a mistype again. That has to be a whole square. Now we'll be dividing this equation by AB whole square. So that would look like this. Now if you notice, the right hand side would change into 1. Whereas the rest of the two ratios will change into sine b whole square plus cos b whole square, which can be properly written as sine square b plus cos square b is equal to 1. So this is the first identity that we have proved. Likewise, we can prove the next one. So let's say we have this equation again after applying the Pythagoras theorem, but this time we're going to divide it by bc whole square. So this would look like this, and now if you notice that this term will become 1, and hence it becomes tan b whole square plus 1 is equal to sec b whole square, which can be rewritten as tan square b plus 1 is equal to sec square b. This was the second equation that we have proved, and similarly we can prove the third one, which is cot square b plus 1 is equal to cosec square b. We need to remember all these three identities because we are going to use them in the further questions. So let's start with this question. This question says 1 plus tan square a times 1 plus sine a times 1 minus sine a is equal to 1. So we'll keep the first bracket same and we'll make a group of second and third bracket as we have done in this step. Now if you notice, this is an identity for a square minus b square, so we have clubbed the two brackets together and this is what we've got. And 1 plus tan square a times 1 minus sine square a is the thing that we've got now. But we know the identities already. That says 1 plus tan square a is equal to sec square a and 1 minus sine square a is equal to cos square a. Hence we can rewrite this step as sec square a times cos square a, which is equal to 1. Now we know that sec is the reciprocal of cos, so we have written it like this: 1 over cos square a times cos square a. If we go on and solve it further, we can get 1 is equal to 1. So this is the required solution to the problem. Let's have a look on the next problem here, which says we need to prove that sec a times 1 minus sine a times sec a plus tan a is equal to 1. So here we have kept the first given thing same. Now we have changed the sec into 1 over cos and tan into sine over cos. So we have rewritten the given thing as 1 over cos a times 1 minus sine a times 1 over cos a add sine a over cos a. Now we have got 1 over cos a here and from this bracket we have taken out 1 over cos A common. So that means in the beginning we can write it as 1 over cos square A, because we have 1 over cos square A 2 times in the equation now. Hence it is 1 over cos square A times 1 minus sin A, and this bracket would change into 1 plus sin A now. So this is again the identity. So we can rewrite it as 1 square minus sin square A. This is what we have done in the numerator, and the denominator will be cos square A. But we know the identity for the numerator now, that 1 minus sin square A is equal to cos A. So we have replaced the numerator by cos square A, and hence it would become cos square A divided by cos square A, which is equal to 1. It means we have proved the given thing, we have proved the asked thing, hence this is the required solution. Now we've got some practice questions for you. This is question number 1, and this is the rest of the questions. So if you want, you can pause the video and try all the questions by yourself. Thank you for watching the video. For more, please log on to justtutors.com.